It wasn't disable your sound. It wasn't like your sound was disabled. It was the button for I can silence you. Sorry, I'm still getting used to all these like slightly different user interface on your chair.
Yeah, yeah. If you haven't shared anything in a while, it's a little bit
The,
different, but it's not.
the locking queue is new and it's really nice.
Yeah.
So,
We'll give it another minute or so since I still see the numbers slightly climbing. And I don't think our agenda is that tight. All right, now I no longer see it climbing. So let's go ahead and get started. This is the Dane authentication for IoT service hardening, or DANCE. Actually, that title is the old title, isn't it? Anyway, I am Wes Hardiker. I'm here with my co-chair, Paul Wooters. That is the mailing list, and that is our official icon for IETF 112. Hopefully I'll find other official icons for the future. As a reminder, I'm sure you've all seen a slide like this for many times during the course of the week. By participating in the IETF, you're going to agree to follow IETF processes and policies, and you should be aware about contributions that you give to the IETF and the related patent-related decisions and things that go along with that. I'm not a lawyer, so I won't try and summarize that more. There's a bunch of BCPs, or best current practices, that are about that in particular, including anything from Internet Standards Process to working group processes to anti-harassment to the Code of Conduct, copyright, and patents. Specifically on the Code of Conduct, one of the things that we are trying to do is make sure that all members of the IETF are welcome to participate and are treated with respect. Please do speak slowly. English is not the native language of everybody. Dispute your ideas by reasoned argument, not by emotional statements. I think that's something that I was just talking to high school students about this week. It's a good rule of thumb. And use engineering judgment, find the best solution for the whole internet. We're not here to design just corner cases, and then contribute to the ongoing work of the IETF by participating in the mailing lists and the general discussion of pushing all of the work IETF forward over time. It's not a single meeting. Do be aware that all of these rules do apply to the Jabber MeetEcho IM system too, not just the microphone, because everything is logged permanently on web archives and also in YouTube. For working group information, we have a data tracker. You've probably seen it. And the purpose of Dane in particular is to extend Dane to encompass TLS client authentication, which is what we talked about in the BOFs that we had about how to use certificates to do client authentication, and not everything under the sun. That's where we're starting. The mailing list information is there. Hopefully you are all subscribed. The mailing list has been kind of quiet. It's time to stir up the pot a little bit, and hopefully this meeting will be able to kick that off as well. And then there are 3 drafts that we'll talk about today as well to bootstrap our working group. So welcome to the inaugural meeting. The chair introduction is being done. Tim has agreed to take notes and is hopefully in the MeetEcho, or in the notes.ietf room right now. I see he has notes in there already, so that is working. Is there anybody else willing to be a backup note taker that can help him out?
I would just say, not even so much backup, but just watch what I type about you, because people type a little faster than I type. So I sometimes, miss stuff.
Right. Is there anybody that can make sure Tim doesn't get things wrong? How's that?
So I figure the speakers can, double check what I'm saying about them.
Yeah.
So
I will certainly try and follow some too. But David Lawrence, can I call on you?
You calling on me?
Yep. Can you back up Tim on notes?
I suppose I could do that.
Thank you. It should be really just watching Tim type. All right. Well, thank you to both of you for
one of my favorite pastimes.
Yeah, it's not mine. It's not mine either. So, all right. So our conversation this morning, we'll talk, the way we've structured it is we're going to talk about use cases first. I think one of the things that came out of the BOF was people weren't sure exactly how it was going to be used or where it might be deployed. So we've put together 3 use cases this morning for how we expect the dance outputs or the TLS client usage to work in various mechanisms. And then Ash will talk about the architecture document that he started. Thank you so much for getting that started, Ash. And then Shuman will talk about some of the existing solution documents, and we'll end with any remaining time for open mic if there's future follow-on stuff. Okay, so with that, I think we'll turn it over to Bill.
So I'm going to hit the ask to share slides and see what that does. One of you guys now need to hit some button or something?
Did you ask?
Mm-hmm.
Oh, yes. There it goes.
Okay. Oh, great. Okay. So that's the, let's see. That one, I guess. Share. No, not that one. Sorry.
You hit slides up.
Apologies. Actually, here. Well, let's see. I'll just ask to share screen and see if that
That
was
would work too.
No, I didn't change my mind. Yes, I want to allow. Whoa! Where were we? There we go. Okay. Sorry. View. Slideshow. There we go. Everybody sees that okay?
Yes.
Great. All right. Whoa, now it's advancing automatically. All right. So basically, I'm not going to try and go into any great technical detail. I'm happy to answer any questions in Q&A, so forth. I'm just going to try and give an overview of the use cases that I am aware of. So one obvious thing is that using Dane to secure the DNS is a demonstration of good faith, eating our own dog food, etc. And it feels to me kind of ridiculous to do anything else. So I think, as a matter of principle, we should be using Dane to secure the DNS. In addition, CA certs are one of our big known vulnerabilities at this point. The CA cert system is trash, and anybody who wants a CA cert saying that they're somebody else has no particular difficulty getting it at this point, and so those little green lock icons don't actually mean anything, and I sure as hell don't want to be depending on them for the DNS as well, although that's kind of where we are right now. So there are obviously people who ask why worry about transport layer if we've got end-to-end security in DNSSEC. So DNSSEC is fine if you actually validate in the client, but nobody does. And when I say nobody, I mean, you know, it's not built into the OS in Mac or Windows or, you know, most Unixes. And the zone data was protected up until the point which it was signed. And that's something I think a lot fewer people have visibility into, but you know, we do, and what we see is really scary. So I think we really need automatic tools there, things that are applied by default rather than assuming that the people who have the unsigned zone data are fully capable of defending it against attack. And DNSSEC is fine if everybody's going to see the same records, right? If you're never going to distinguish between different people and hand different records to different people, then no issue. But that's also something that people want. So DNSSEC, great for authenticating content, but doesn't deal with authorization. And we already do authorization throughout the DNS publishing chain. We just do it in a variety of awful hacky ways. And what I would like to see is one nice clean way that applies at every stage here. Like each of those little red arrows is done the same way, not using a different hack. So if we look at the beginning of the chain, the stub and caching and recursive, we've got this problem of split horizon, where people in enterprise do a lot of split horizon. They depend on a lot of split horizon. Everybody gets that's ugly and not a good idea, but you know, we also get that it's not going away anytime soon. So what do we do with people working from home and, you know, COVID and zero trust security and so forth? We need some way of supporting split horizon that does not depend upon an ass in a seat in an office in a specific location. So TLS client authentication solves that problem very neatly. The hack that people are mostly using right now is using VPN authentication, which is built into OSs. You hand somebody a unique IPv6 address, and then in the name server, in the recursive server, or the caching forwarding server, you give them different answers depending what IPv6 address the query is coming in from. It's a thing that you may already be having to do for some reason anyway, but if all you want to do is give somebody a different DNS answer, it's a very heavyweight mechanism for doing it. It requires a lot of moving parts that are sort of outside the DNS. There's also a huge demand for closed community recursive resolvers that are not public recursive resolvers in the sense of answering any query that comes to them from anybody on the internet, but are recursive resolvers in the sense that an enterprise would have had them internally prior to zero trust, work from home, blah, blah, blah. So we have people who want to run a recursive resolver that has a closed user community and is not answering for anybody in the whole world. So we need a way of authenticating the client for that. And again, that's, you know, people are trying to do VPN auth for that, which is a hassle. Between recursive and authoritative, this, again, isn't probably visible to everybody, but there is a huge amount of IP layer prioritization that happens between authoritatives and recursives. So if you're operating a large authoritative, you have a list of the IP addresses of all of the major recursive name servers, all of their upstream transit interfaces, and you try and keep that list up to date. And when a DDoS comes in, those are the IP addresses that get the answers first. That is an immense headache. You know, we've got Google, Quad9, Cisco, and Cloudflare at this point. And, you know, they've each got anywhere between 30 and, say, 500 IP addresses in v4 and another 30 to 500 IPv6 addresses. And anytime they're changing, we either have to sort of deduce that by where queries are coming from and, you know, patterns and so forth, which is a mess, or we have to communicate it. And that's really just not anything we want to be having to communicate. As a recursive operator, I don't want to be having to tell every major authoritative operator what every IP address I'm using for transit is. And as an authoritative operator, I don't want to be having to track all the IP addresses of all the recursive operators. If I could specify a recursive operator by domain name and see a client cert that matched that domain name and know that everything was good, that would be much, much cleaner. Then we've got the authoritative Anycast to the hidden primary to the DNSX signer. That section is all handled with XFR and TSIG and so forth. That all works, but TSIG is shared secret, so it's super clunky. And the net effect of this is that people wind up reusing TSIG keys across multiple sessions, multiple partners, you know, organization to organization. They may have a unique key, but then they've got a whole bunch of servers on each side and they're reusing there. Having TSIG keys floating around in configuration documents, in documentation, in email, in chat, you know, it is a vulnerability. Again, TLS solves this problem. And then lastly, the thing I mentioned up front, zone data is typically authored on a machine and by parties who are not capable of doing DNSSEC. For the vast majority of zone data that winds up signed, the person who authored the zone data is not the one who's applying the zone signing keys to it. And getting the zone data safely into the DNSSEC signer, the person who operates the DNSSEC signer may be perfectly capable of securing everything downstream from that. But the upstream side, you know, it's one of those situations that we hope nobody looks very closely because garbage in, garbage out. So having something that worked by default, that gave transport layer security between the authorship of the unsigned data and the signer would make, you know, give me one fewer reason to chew my fingernails. So that's it for me. I think we need to be able to authenticate both parties of any DNS transaction wherever it is in that chain. I think TLS bidirectional auth is the only reasonable way of doing that. I think DANE TLSA records are sort of the reasonable way of getting TLS keys distributed at scale, but you know, your mileage may vary and I don't really care how other people do it. I just need, you know, the DANE TLSA stuff to be supported in clients. That's basically it. I just think we need one solution here, not a whole bunch. So that's it for me.
All right, thank you for that, Bill. As a reminder, you know, not everybody has to agree that all of these use cases are for them, but we're just trying to find some of where different people will apply this resulting technology. DKG, do you have a clarifying question? We're not going to do much discussion or bashing about things. Nope. Okay. Victor, you have a clarifying question.
Clarifying. One of the things Bill didn't mention is using DANE TLSA to authenticate ongoing maintenance of DANE TLSA, or at least I may have missed it if he didn't say it. So I'd like to see that discussed, because if we're actually going to rely on it, we also need to be able to keep it working.
Bill? You were there and then you left. It is possible that DKG.
I just wanted to ask Victor to say a little bit more about what he means by maintenance. I didn't understand his question, so I'm asking for clarification on the clarification.
Fair enough.
Okay. What I mean by that is that some people are in the habit of publishing DANE TLSA records and then not doing a good job of keeping them correct as they roll with certain keys. In part for lack of sensible mechanisms to make changes to the DNS, in part other kinds of planning things that I may be able to help them with software for. But I'd like to see name servers provide a Dane-based mechanism to keep Dane records updated, not just initially published.
Okay. Victor, DKG, do you have more? Is that an old hand? No.
Yeah, no, this is me back again. Thanks, Victor. I understand that now. I do have a clarifying question about the use cases here. The use cases that were presented, I think, are well motivated. I see the need for something that solves those problems, but I am not entirely convinced that client authentication is the thing that's needed to solve those problems. So
right, I just led with that a minute ago, right? That not all of these cases, you may want to solve something differently, but this is where people might want to deploy it. We're not actually arguing that this is where we are targeting, but it's at least a use case to consider when we're developing a protocol. Right?
So
we're not actually
typically we do this.
Sorry, go ahead.
We typically do it the other way around, right? Where we say, okay, what's the problem that we're trying to solve, and then what are the possible protocols that we could use to solve it, and let's figure out, what those protocols are. As someone who's seriously concerned about the tying DNS queries to individual identities, I would, if we're going to be talking about how to solve some of these problems, I mean, I think maybe this is I'm more comfortable with the recursive resolver to authoritative authentication side of things here, but the client, like if we're trying to solve the problem of how do we work with a closed community resolver that has special rules, I would much prefer to see a working group like this think about non-client authentication mechanisms that would solve that problem. So if we're talking about that as the use case, I think that it opens the door to a lot more work.
So
if that makes sense.
Right. This is not the use case, or it's not even a guaranteed use case. This is trying to get models around when we're talking about the architecture document and framework that that somebody has the opportunity when they start talking about it later that we've seen a presentation on what they're thinking ahead of it. You are right, absolutely, that that we are not going to take this on as the use case. It is more as we start working on the solution framework. Is this the one that we want to consider in the future? So, Bill, do you have an answer? And then we are going to go on just to get agenda on time.
Yeah, I mean, on that specific thing, blinded certs and role authentication doesn't have to be individual authentication tied to a, identity on a passport.
Okay, thank you. Ash, you have next up, and on device to cloud and the EAP use case are sort of both yours. I will say that I think the EAP use case we agreed would be out of scope for the initial work, but it's still, our initial architecture should enable that to happen at some point, right? So.
Yes, yeah. And so a lot of the stuff that I'm going to be, some of the stuff I'm going to present as context, but it's definitely, how I would like to note that some of this stuff is outside the scope of the charter. Let me get the presenter review going. All right, so first we're going to start with device to cloud, right? So the device to cloud use case is particular to IoT, but it's very close to a lot of other sort of patterns you see even with workstation access to cloud applications. So let's jump in. This is going to be brief, and it's not going to go extremely deep into the protocol, but I do want to talk about two different approaches we might consider for anti-abuse. And so this is some stuff that kind of came up. I was doing some playing around with how this might be implemented, and at least should be recorded, and we should contextualize the way that we build the final standards with this stuff in mind. So the problems that we'd like to solve, you know, in dealing with client
Ash, the
identity.
screen is not yet being fully shared.
Oh my gosh. Okay.
Did you click OK and select the screen and
me-
everything?
I know what I did wrong. Sorry.
Okay.
Okay, there we go. All right, so HTTPS device to cloud use case. There are a variety of protocols that you can use for device to cloud. Sometimes that's MQTT, sometimes that's HTTPS, but I'm covering specifically HTTPS for this. We'll talk about some of the challenges with getting client authentication to work for HTTPS and TLS at scale for a great number of devices. And we'll discuss sort of two, at sort of a 10,000 foot view, two different approaches that we might consider for anti-abuse purposes for the protocol. And then we can have a brief Q&A. The problems specifically that we seek to solve have to do with using public key-based identity at scale. Web applications, and especially when you start looking at cloud applications, the cloud side can get decoupled very easily because of orchestration tools make that easier to do. So you'll have a, you know, your TLS termination might be happening on the front of the application in a dedicated load balancer, and then you'll have web applications behind that. You'll manage client configuration, you know, roles and identifier association inside the application. But you know, when you start, it becomes very difficult to do that with PKI because you may have to synchronize settings between your application and your load balancer, and that can become problematic. Also, problems that you know, that we heard earlier with, you know, the problems of PKI, where you can have identifiers in one PKI may also appear under another PKI, and so naming collisions, impersonation happening that way. Also, when you start looking at smaller organizations that maybe can't good identity strategies like using PKI-based identities are not as approachable because of the infrastructure cost and having to operate your own CA traditionally, or you know, and everything that comes along with that. So what we'd like to do is we'd like to make PKI-based identity more accessible. We think that Dane can do that. And we go into more detail in the architecture document with how that works, you know, having identity suppliers. But the problems particular to doing this with HTTPS, if you have a bunch of devices, you know, consumed by an organization, and they all need to onboard to a cloud application. Oftentimes, you'll see an API to API integration, and this is, you know, between something that's acting as a certification authority and a cloud platform, and they're either moving the trust anchors over, or you may just do a bulk move of, you know, device public keys or certificates, and using DNS just to discover entity certificates by name is a lot, I think, a lot cleaner way to do things. But when you get into the implementation, you know, the way that we've discussed this so far is in having the, during the TLS handshake, actually doing the DNS lookup and doing the Dane comparison. However, a challenge that comes with that is that you really need to have an allow list. If you don't have an allow list, then anyone presenting a client certificate and supporting the Dane client ID protocol could possibly trigger a DNS lookup against maybe a maliciously configured resolver that doesn't respond very quickly. This is sort of a play on the slow Loris attack. and it presents an interesting engineering challenge in the implementation. So this is something that's worth considering. Do we do this part inside the TLS handshake, or is there a different way that we can do this? That might make anti-abuse efforts a little easier to manage. And so we may consider a TLS cooperative client authentication protocol, where you have the TLS terminating load balancer will authenticate a certificate, and in the HTTP headers, or rather in the something like post data, you might have the DANE ID indicated. And so once that certificate's authenticated and you know that the possessor of the private key is on the other end of that connection, the certificate gets passed through to the web application as well as the DANE ID. And so the web application can then look at the ID and make sure that the identifier is actually a valid client for the application before going to do the DNS lookup. And so, in this case, you wouldn't fail you wouldn't have the TLS connection fail. It would be something signaled by an HTTP error code. But this might make for an easier implementation, within some cloud applications. Anyway, these are just some thoughts that come out of doing some test implementations, and for by way of illustration, this is what that might look like. You have the device, abc.device.another.example on the left has a certificate presented in DANE or using a TLSA record in DNS. As it attempts to authenticate to the load balancer is configured to authenticate any certificate to make sure that the private key is held by the client, and then it passes that through to the application behind it. The application behind it then makes sure that the client name that's coming through in the post data is actually on the list of allowed clients, and then it checks that against DNS, and then it can allow it into the application. And so this makes it, comparing this to a situation where one might have to if the TLS handshake is held up to do a DNS query, and the client is able to sort of game that process to have a bunch of TLS handshakes open at the same time, that might be a DOS opportunity. So there's probably a really good way to solve this in the TLS handshake, with managing timeouts or making sure that there's an allowed clients list. But this is, anyway, this just shows maybe two different approaches we might consider for mitigating abuse on the application side. And we can go to Q&A.
Ben, clarifying questions?
So are you, okay, I will phrase this as a clarifying question. Are you assuming that the client does not ship a complete DANE cert chain or a signature chain?
The expectation is that the client will present a certificate, and so are we talking about the sort of the TLS native method or the HTTP method?
So I neither. I am attempting to argue to you that the right answer here is for us to say that the client needs to ship a complete signature chain to the DNS root.
Okay.
So that the server has no work to do. And so I agree that these are real problems. I just think we should completely prevent them.
I think that's a great idea.
Are you suggesting, Ben, that you actually send the DNS keys and the signatures all the way up to the root so that there's no DNS queries that need to be made?
Exactly. The server should not have to perform any network operations or rely on any caching in order to validate the client identity.
I like it. That sort of unwinds the whole problem.
There was sort of that discussed in TLS at one point. All right, Victor?
I agree in part with Ben, but I wonder whether that should be an optional feature. If some server wants to ensure freshness of the data, the client may be shipping slightly stale information, right, subject to RRSig and all that. It should be possible to do that. We may need TLS extensions to negotiate which of those scenarios happens.
Engineer that at the moment, because the only reason I'm doing clarified questions is that we can get to all of these when we get to the architecture discussion. So, Shuman?
Yeah, so I think that's an option we've discussed in the past. We haven't written it down anywhere, but the possibility is we have a mechanism that can kind of do that, right? The TLS chain extension, which Victor is very familiar with too. Only then we would have to kind of configure it to go the other way from the client to the server rather than the server to the client, which is how it was originally envisioned to work. But I think that's a possibility that could be implemented as part of the dance work if there was interest.
Okay, thanks. So Ash, we can go on to the EAP case.
All right. Just a moment. Let me get this going.
Been asked to use the PDF sharing version of in MeetEcho because it takes less bandwidth, but we'll work on that in a bit.
Okay.
For now, go ahead.
So the ETLS use case is a network access use case, and this could work for wireless or wired access for devices. And so similar flow to the last one, except a little bit less into the protocol. We'll talk about some of the challenges with client identity, and then we'll look at how Dane maps to the use case. The challenges with ETLS supplicant authentication, and supplicant is the TLS client in the EAP authentication process. So, or ETLS authentication process. It is prohibitively expensive for small organizations to adopt this authentication mechanism, and that comes with the expense of operating a PKI or certification authority. And so it's also limiting when you implement a PKI because you create your own namespace that is local to the organization or to the application, and you know there's a time factor in that as well. And this is, you know, very often you see this in use in enterprises, but small businesses and smaller organizations, it's more difficult to adopt. And then that identity, if you have an identity issued by your home organization and say you're a contractor and going to do work for someone else, you can't use your home organization identity at a client site to access, you know, guest wireless, for instance. And so if you think about, you know, the hoops that we oftentimes see organizations jumping through to implement something that you know, that isn't too complicated for guest wireless access, having time-bound tokens and everything like that for accessing a very specific network. It's there are a lot of hoops and a lot of automation that kind of comes into play. And I think that using Dane for client identity can cut through a lot of that unnecessary complexity. So using Dane for the supplicant identity gives us one device identity, and because it's represented in DNS, you can use it, you know, potentially across different networks, different providers, and you can and it becomes pretty easy to configure an access list even across organizations because you're just working with DNS names. You get revocation at the speed of TTL. So you pull the record from DNS and it can't be authenticated. And so that's a really good way of, disowning a device that might be compromised. And then you also get the benefit, of having a third party, or a manufacturer providing an identity that can then be consumed by an organization and used without them having to operate their own PKI. And so that's how you kind of get to a very low friction PKI onboarding process for the network. And then you have the use case for even leased devices. And so if you have one organization that provides devices and to another organization, onboarding those to the network becomes very easy. You can say, well, I allow, you could even do a wildcard match, to say, well, I allow any camera coming from this vendor to access this portion of my network and things like that. So it gives a lot of flexibility, and you can be very, you can use wildcards, you can be very specific, but it seems to be a really good way. And I keep coming back, I guess, in my mind to the analogy of using network access lists and how that, makes sense, for network flows higher up in the stack, using DANE identities to describe interactions between clients and servers seems like a much easier way to do things. And so, the way that you might, the specific onboarding process for an implementer is they might, have get the device in hand, and add that DNS name to the network access list, configure the device with the Wi-Fi SSID that it needs to attach to. And for traditional CA-based authentication, then you would install the CA certificate for maybe the Radius server that's performing the other server side of the TLS connection. We have discussed, passing, passing the DNSSEC chain in the TLS handshake. That might be a way around having to install a CA certificate. But that's something we've discussed. It's outside the scope of the charter, but I think it's definitely worth consideration because that would make it DANE end to end both ways. And then your network bootstrapping is complete. And this is without having to, to deal with the process of, signing a certificate or issuing, a device identity. It arrives with a usable identity, and getting it onto the network is just a matter of a couple of configuration items. The way that this might look is a vendor supplies the implementer with devices, and the vendor places those device certificates or public keys in DNS. The implementer configures network access. It just adds the names of the devices into the Radius server's access list, for instance. And then after configuring the devices to point to that access point or whatever, then those devices are able to authenticate and be authenticated by the Radius server, just using the DNS name to do the certificate comparison using DANE. Thoughts, clarifying questions?
Any questions?
Hi, this is Daniel again.
Yep.
Josh, thanks for presenting this. How are you imagining a client selecting which identity they want to present in this use case?
The client deciding on which identity to present to the network.
Yep, that's the
I'm
question.
getting a little background noise. I'm having a hard time hearing you. That might be my side. I'll mute. And could I get you to restate your question?
Yeah, so I'm trying to understand how a client would be expected to choose an identity when doing EAP, right? I think the use case you described is sort of a distributed one where the client is using the same identity to multiple providers. And I'm just wondering if you have any thoughts about how a client might, like, is this going to encourage people to always, publish their citizen ID as they make a connection, or do we think that people are going to be able to, like, do you see this as something that would be relatively easy for a client to select which identity they use for any given network? Like, what are the sorts of UI affordances that you would need to avoid one person having to present the same identity everywhere?
That's a really good question. And so I think that protecting privacy is super important. This might be a case where you have multiple identities. Having identities issued in this way, in a way that doesn't require the implementer to operate the PKI, you could purchase a number of identities from an identity vendor like this. So if I go to, identity.example, and I purchase, a number of PKI identities to install into my device, then I might be able to select one. And depending on the network I'm accessing, if it's a public Wi-Fi network, maybe I just randomly pick from whichever one that I want. The original driving use case for this has a lot to do with IoT, and in the IoT use case where you have, and I'll use a specific example, the ESP32 system on a chip has like 4 megs of flash storage. And so you're not going to squeeze a whole bunch of certificates onto that, certificates and private keys onto that device, because the storage is really constrained. And so I think with a lot of IoT use cases, especially when you start getting into that borderline close to the low power stuff, it'll just have one identity that it'll use for a variety of networks. And with, when you consider, if someone leases a bunch of smart light bulbs and they want to use ETLS for them, then the idea is that you would, onboard these devices, but they would use a manufacturer issued certificate to access an enterprise network. It definitely bears some consideration privacy wise for users, and that's we should make a note of that and make sure that if we start prescribing this for user access, then we have some privacy protection in place.
Okay, thank you. Let's go on to Victor, and then we really need to get moving. We're a little bit behind, but we do have a buffer today. So, Victor?
Yeah, I'm just concerned, as always, about this long-term stability of vendor credentials, right? Vendor sells you a light bulb, and tomorrow they're gone. So I'm skeptical about this use case. Sorry, Wes, not a clarifying question, but I think it's an important consideration to cover.
Right. So we will talk about that when we get to actually solving that problem. But fair point.
Right.
All right. So Ash, let's go on to you're actually also up for the architecture presentation, right? So instead of, if you could unscreen share and then use the second button from the left, which is in between the screen share and the hand icon, to share using that slide deck instead, assuming your slide deck is up too. That should save bandwidth for some of our downstream users. Thank you very much.
Perfect. Dance architecture. All right, and so sort of diving into the architecture document, which was a part of the original scope of the working group, is to produce this architecture document together with guidance for implementing Dane client identity in the TLS handshake.
So you're very lucky for me. Could somebody else in Jabber say whether it's just me or not? Keep going, Ash, and then we'll.
Okay.
Oh, it's just me. Never mind. Go ahead.
So similar flow to the other presentations, we'll start with the problems. We'll look at how Dane maps to the problem space, and then we'll go through some of the use cases where we think it might fit. And before we get too far into this, disclaimer: this does, in the interest of painting a larger picture, this does include some non-chartered items. So we talk, later on about what if object security were part of this. This isn't intended, to require the working group to go in that direction. This is to say, in the fullness of time, and if there were interest, beyond a rechartering, this is what a more complete ecosystem might look like. So I wanted to preface this presentation with that. Again, the problems with PKI-based identity is it's too expensive. Smaller organizations can't adopt it easily, and it doesn't really work very well across organizational boundaries. It's operationally burdensome. That comes along with the expense. You have to have people to, if you're doing it right, then it's not cheap. You have to have people maintaining it and protecting it. And resource-constrained organizations are left vulnerable because it's hard for them to adopt. And then the restrictive, I've already kind of spoken to this before, but getting trust to work across organizational boundaries and using policies within the, within the context of PKICs is sort of a challenge. And then you still, one PKI does not have a way of preventing other PKI from signing identities with the same identifier. And so the challenges that come along with that, it's really complicated. It's unnecessarily complicated, and I think we can solve this with Dane. Already talked about that. So let's talk about best practices for a second. The Cloud Security Alliance recommends that in their summary guidance document for identity and access management for the Internet of Things, they say that step 1A, you should define a common namespace for your IoT devices. And that makes a lot of sense. I think most people would pretty much agree with that. And so from this decision point, a lot of architects will say, all right, well, I want to use, this strategy or that strategy. I want to, indicate the taxonomy of my device. It's from this vendor. It does this thing. This is a serial number, or maybe it's just using the hash of the public key as the identifier. But then you end up, when you're trying to troubleshoot an audit, you then are describing trust, trust relationships between entities represented by two different namespaces. And, what if instead of creating a new namespace for clients, we just use the one that we use for server identity, and that's DNS. And so using Dane for client identity, PKI namespace being bound to DNS, it's recognized wherever DNS is used. We all agree on the DNS, and it's not like, if you stick something in blockchain, then the next question is, well, which blockchain is it in? And what does the API look like? And it gets, sort of complicated. Using the DNS namespace, it's everywhere. You get the ability to look up public keys by name, and a lot of the challenges, with using traditional PKI, dealing with RESTful APIs on CAs, just goes away. Organizations are then able to purchase devices or lease devices with identities that are immediately useful. And so that takes the burden off of the implementer, or the consumer for, provisioning that PKI identity, and the network onboarding process becomes a lot easier. Adding a device to a network means adding the DNS name of the device to the access list. Allowing application access means that you add the client's DNS name to, an access list or a role inside an application. And for the object security use case, using DNS for public key lookup, for signature verification or object encryption, it flows really well, works across organizations, and the complexity that you have of integrating different APIs just goes away. If DNS is the API, then the SDK's already built into the operating system. The example that I'll walk through is one of, let's say, an autonomous car use case. And the cars.example organization has autonomous cars that they allow to drive around a city. And the city falls within the jurisdiction of gov.example. Gov.example says you're only able to drive that on certain roads that we say are okay. And you have to report where your cars are driving regularly. And so these autonomous cars also generate lots of data while they're driving, the sensor readings, things like that, all kinds of telemetry pictures. And so they frequently need to upload this stuff to a cloud storage platform for parsing and for training machine learning models, things like that. And so the cars.example organization has a relationship with ISP.example. ISP.example runs a bunch of consumer premise equipment all over the jurisdiction, and so they're able to stand up a Wi-Fi SSID that's more or less pervasive everywhere these cars are going to drive. And so this allows the car to, or any car in the fleet, to access these networks for periodically uploading, these massive amounts of telemetry. And so looking at that universal client credential, let's just say that you use the same credential for network access as well as everything else. In some cases, that's not ideal, but for the purpose of simplicity, that's how I'm going to describe this use case. So car is driving down the road, and it has the car's configuration says that it knows that it can authenticate to public.isp.example. SSID is named public.isp.example, and so as it's driving along, it detects that SSID. If it needs to upload information, then it's able to do ETLS client authentication to any of those access points as it's driving around the city, and it can use that to upload information to the storage platform, or for internet access, updating maps or machine learning models, whatever, general network access. And so that same identity works when it pulls into the parking lot at the home office. And so it can use the same credential to access wireless.cars.example. And uploading telemetry to API.cars.example might, it can use that same client certificate for mutual TLS authentication with that RESTful API. And then it can use that to upload whatever information that it has. And for compliance purposes, it submits a JWS of different points of in space and time where that car was, so that the government entity can confirm that it didn't go outside of its allowed geofence. And so the way that interaction happens is the car uses its certificate as a client certificate to perform mutual TLS authentication with an MQTT server, and it places that signed JWS document onto the message broker, and so the document can then be saved, and it can be verified later on when it's parsed and compared against its allowed geofence, because the JWS document contains, in addition to the payload, it also contains the DNS name where that public key can be retrieved for authenticating the object. And so what we have here is we have a car that uses a single identity represented in DNS, car54._device.cars.example, and it uses that identity to perform ETLS client authentication with multiple wireless networks, ETLS client authentication with multiple wireless networks, TLS client authentication with its home organization's API server, as well as the report.gov.example MQTT server for delivering that sort of the geolocations and times. And then the gov.example can then reach out through DNS to do a public key lookup to verify the messages that are placed in queue by the device or by the car. What we see as possible protocol use cases, and these are listed in the architecture document. Start TLS for the email ecosystem, EAT TLS for network access, HTTPS, and MQTTS, which are particularly useful for IoT, SIP and WebRTC, as well as some use cases for LoRaWAN. Object security, should we decide to go that direction after a recharter, Jose and Cozy, make a lot of sense. There are some metadata fields already defined where this fits really well, and XMPP end-to-end encryption seems like it also might be a really good fit. And client public key discovery for SSH is something that might be worth considering later on as well. And we should also bear in mind as we do this, even though this is not going to be defined, necessarily in our, within the scope of our charter, we should also keep in mind that anti-abuse efforts can really be aided by having a good, solid identity, especially where the identifier indicates the owning organization. And so, being able to report misbehaving devices using a DNS name, sort of takes out the, so some of the what might be subjectivity in processing a distinguished name from a certificate or client common name. So these are things that we should keep in mind. For security's sake, I think it's important to recommend DNS over TLS. For integrity's sake, the stub resolver should be doing DNSSEC validation. And availability-wise, we talked about mitigating this with using the TLS chain or the DNSSEC chain and the TLS handshake, but only performing a DNS lookup for allowed client names is a pretty good way to, close the gap that could be exploited. And a few links to the working group, the architecture document in Data Tracker, as well as GitHub. And now we can jump into Q&A.
I accidentally killed your video, Ash, if you want to bring it back. Sorry about that. Anyway, so Q&A. So anybody have questions about Ash's presentation? I will say some of those items, were out of scope again for the working group at this point. The goal is to create an architecture that may be usable for lots of cases. Like ETLS, for example, is even, I think, declared out of scope initially and things like that. But enabling it if the IETF wants to take on that work in the future is important. Anybody have questions or comments? This is a time to talk about the architecture, regardless of this is not just clarifying questions at this point. We do have time for discussion. I think one of the outstanding questions in my mind is in the architecture document where I believe that we need to talk about naming of entities and make sure that architecture framework, marries with the rest of the IETF terminology, as well as pick the best example, use case that we can state what it's going to look like architecture-wise and explain it. So, Shuman.
So this, since the architecture presentation that Ash did talked about some future-looking use cases too, I just wanted to go back to the suite of use cases that we did discuss prior to that, and the one that I mentioned this on the chat too, the one that I noticed that was conspicuously absent was the SMTP transport security use case. And I was wondering if we could volunteer Victor to say just a few words about that, just to make sure it's on people's mind.
Well, Victor does happen to be in the queue, so didn't have that in a slide deck, but probably I should have probably poked Victor to make him present slides. Victor, do you want to talk about the SMTP client use case of this at all?
Sure, I can briefly describe the issue. So the SMTP client that I was interested in way back when Shuman started that draft is an MTA, not an end user with a mail client. And in the MTA to MTA use case, the clients aren't trying to hide their identity. In fact, they're trying their hardest in most cases, to convince the server that they're legitimate and should not be spam filtered. And it would sure be nice to be able to not only have audit trails in SMTP received headers that show you that a message came from, a source that you can trust, but also to be able to apply reputation to instead of IP addresses to pre-trusted domains. We do some of that these days with DKIM and DMARC and the like. Those are end-to-end signals that tell you who wrote the message. But it's also useful to have transport security indication in this case, MTA to MTA. And with Dane, we could onboard that, incrementally negotiate its use. So the goal is to be able to know who's talking to you as an MTA, SMTP client. So that's all I wanted to say about it, unless people want me to say more. I don't know what else there is that people want to know about.
That's probably good unless people have questions, but you also stood up to get a question probably too, right?
Yes, which I will try and still remember in this case. All right. It's a question and sort of a comment. One of the things we're not talking about in this charter is any kind of exchange of credentials. You might start with DNS to authenticate yourself to some point in the network. But having achieved that, having authenticated to some sort of authentication provider, we then need to think about whether that's the whole story, or whether we, federate, sort of in some way, trust brokers of various sorts that can then authenticate you to other networks by other means than this mechanism. Is there a more complete architecture here? One of the things that I had been looking at but never had cycles to do was, in fact, bootstrapping cross-realm Kerberos with Dane, which would allow KDCs to authenticate each other, and then make it possible to have a Kerberos mesh that's kind of internet scale by using Dane between the KDCs, but then user authenticates to local KDC, not to some remote entity. And KDCs have wonderful things in terms of, probably Dan Gilmore will be happy to hear KDCs can support anonymous credentials. KDCs can do all kinds of renaming and masking and so on. Having authenticated the user, they might then present them with a credential that authenticates only the organization and masks the user identity. Things that can't easily be done if the architecture is, single party all the way to the end. And this is a much bigger problem, of course, but I think it's the more ambitious architecture has some merit. We ought to think about what is the full life cycle. Is there a federation story here? In addition to DNS being federated, in terms of trust and so on being federated as well. Of course, I don't know if people have appetite for these larger architectural questions, but they come up.
Victor, Paul?
Thank you. So this is related to the architecture draft. There's a question about scalability. You mentioned that a client identity zone is essential for actually authenticating. But in the event, let's say the client identity zone goes offline or it's unavailable and you're not able to authenticate, do you look at the possibility of a fallback solution? Do you intend to actually discuss maybe a fallback solution in case such events occur?
That is certainly worthy of discussion. We didn't put that in the architecture document for fear that it would, that could be a whole other sort of area of study that could be addressed maybe by a caching strategy on the server side of the TLS connection, whatever application that happens to be. But it's, if that's worth pulling into the architecture document, I'm happy to, and getting some discussion around it, because having a good fallback mode could be useful.
It's definitely an interesting use case. The or not use case, side effect, and actually putting records into the TLS client certificate, actually, that was discussed earlier, is potentially one way around that, right? If the DNS key verification all the way to the top, for example. Victor?
In terms of scalability and fallback, it sounds a bit like using Dane not for every ongoing authentication, but for enrollment. So you present your Dane credentials initially when you first interact with some party, and then in many cases you might obtain a bilateral credential, and future interactions don't require it.
Yep, good point. All right, well, I see the queue is empty, and that's probably good because we're right on time to switch to Schumann and the two existing solution documents. So Schumann, whenever you're ready to present your slides, ideally using the file sharing mechanism over the screen sharing mechanism, that would be good.
Okay, so how do I do that? I don't think I've...
It's the one
Is it asked to share slides? Is it that one?
It's the pre-loaded slides. It looks like a file icon with a slash through.
File icon. Oh, it's
There's
on
a
the
hand
top
icon, which you know is, yeah.
And forgive me, I'm trying to find it.
I can share it if you'd rather.
Yeah, actually, if you don't mind, could you do it?
Sure. And the name of your use case, so let's see, client authentication, is that it?
Dane TLS client authentication, yep.
There you go.
All right, okay, so I'm going to do a quick overview of what we think are some of the initial protocol building blocks for implementing the dance architecture and the various use cases that have been discussed. Now, we've gone through a little bit of this already during the BOF sessions leading up to this point, so some of you may have seen bits and pieces of this already, but now that we finally have a working group, I think it's useful to kind of rehash and refresh everyone just to make sure we all have a common understanding. So we have two drafts listed. The first is about Dane client authentication, and the second is about a TLS extension to convey a client's intent to be authenticated by Dane and optionally to actually convey the full client identity as well. So next slide, please, Wes. The goal is to be able to authenticate the client side of a TLS connection with Dane. Today, as many of you may know, Dane is used primarily to authenticate TLS servers. So this mechanism is about extending it to do client authentication too. A little bit about the history. These drafts were originally written quite a while back. In fact, we presented this work back in IETF 93. That was the summer of 2015, believe it or not, in the Dane working group, which existed at that time. And there was quite a bit of discussion and interest at the time, but then the Dane working group shut down because it had finished its original charter of work and this item wasn't on that charter. And kind of the authors didn't really have the time or energy to continue pursuing it. But the original target use cases at that time were IoT device authentication and also authenticating clients in SMTP transport security. I think those use cases are still valid, as you've heard today. And it looks like there are several more application areas that may benefit from these protocols too. So next slide. A quick protocol sketch. Basically, the TLS client is expected to have an identity in the form of a DNS domain name, a public and private key pair, and a certificate binding the public key to the domain name. And there is a corresponding Dane TLSA record assigned and published in the DNS. The TLS server sends a certificate request message in the handshake, and the client in its certificate message includes a Dane client ID extension. I'll describe that extension in the next slide. The TLS server then extracts the client's identity from the presented certificate and then obtains the DNS TLSA record, authenticates its signature, and validates its sort of record data against the certificate or public key in the certificate. Next slide, please. Okay, so there's also a proposed new TLS extension for conveying a client's DANE identity. So generally speaking, the TLS server can find the client name in the client certificate itself. So why would we need this? Well, it has a couple of purposes. First, to signal support for this protocol, which can be done by the client just sending an empty extension. Technically, both the server and client could signal this capability advertisement. It's particularly useful, though, for the client to do this, because then it can communicate to the server that it has a DANE record that it wishes to be authenticated with. And in environments that may support a mixture of clients, we can ensure that the TLS server attempts to do DANE authentication only for the clients that are suitably configured to make that possible, right? And secondly, this extension can be used to convey the actual client's DNS identity, namely their domain name, in cases where it may be required. So there's two cases where it's probably required. The first is if clients are using raw public key authentication. That's RFC 7250. I think I don't know of anyone that has actually implemented that in the field today, but it's certainly a possibility that can be supported by the DANCE architecture. So in that case, there is no certificate at all from which the client's identity can be extracted. So the client has to communicate that in some manner, and this extension can be used to do that. Another case is if the client certificate has multiple identities in it, and we want to be able to kind of surgically tell the server which specific identity has a DANE TLSA record associated with it to kind of minimize the amount of unnecessary work the server might otherwise have to do to hunt down which of those identities has a DANE record. So I also want to make a note about the privacy implications of this extension, which was kind of brought up when we originally talked about this drafts, because we are potentially sending the client identity in the extension. So when we first started this work in 2015, we didn't really have a good solution to privacy protection at the time, but now we have TLS 1.3, which does address this. So in the TLS 1.3 version of this protocol, the extension is intended to be carried in the certificate request and the certificate messages, which are both encrypted, so there's no privacy leakage. In TLS 1.2, the client has to send this extension in the first flight client hello extension, so this can't be protected today without further enhancements to that version of the protocol, which seems kind of unlikely at this point. So depending on the application, this privacy leakage may or may not matter to you, but we advise using TLS 1.3 if possible. Next slide, please. The TLS, say, record format for client authentication, sorry, the record data format is exactly the same as defined in RFC 6698, the DANE spec. What's different is the record owner name format, which has to be adapted to something more suitable for client names. So the spec currently proposes two formats that we think have wide applicability, but I think we recognize that applications could choose something else if they needed to, and the draft is trying not to be prescriptive on this point. So the first format is what we're calling service-specific client identity, and it allows for the same client to have different credentials for different services by encoding the service name into the first label of the domain name. And it also accommodates wildcards if the client uses a common credential across many applications. So in the original version of the spec, in going back to 2015, we had actually proposed the use of different subject alternative name types. So there's something called SRV name, which is described in 4995, which supports kind of like a more flexible way to encode application-specific identifiers. But in the end, we kind of assessed that nobody really uses that in the ecosystem at all, and we kind of took it out. And instead, now we have this format. Next slide, please. The second format is what we're calling IoT device identity, and proposes organizing IoT device names under a common suffix using what we call an identity grouping label. So that's underscore device that you can see in the second label in this example. And this scheme permits an organization, if they wanted to delegate the management of the client device tree to a third party that could offer, DNSSEC signing services and maintenance if they wanted to. So to the left of the underscore device label is the device name, which could be composed of a number of labels, and to the right is the organizational name, which may include other labels within the organization, not just the kind of top level zone of the organization. And next slide, please. And here's a kind of just a made-up example of what an IoT client Dane record might look like, and this is straight from the draft. And let's just move on to the next slide. And here's a general diagram of the protocol flow. It's just some minor enhancements to the typical TLS client certificate authentication flow. So I've just pointed out the main deltas in red here, namely that the Dane client ID extension is sent along with the client certificate from the client to the server, and that the TLS server needs to perform a lookup of the client's Dane TLSA record and validate the client certificate of public key against the contents of that authenticated record. And next slide. I've also tried to annotate the TLS 1.3 handshake message flow with the new protocol elements. This should be fairly self-explanatory to folks familiar with the TLS protocol. But so this slide is the vanilla TLS 1.3 handshake. So let's move on to the next slide. And in red, so this part is optional. So originally this wasn't in the spec. We only had, it was kind of a one-way extension from the client, but some people argued to me that it may be useful for the TLS server to advertise that they support this capability. So that can be done by optionally sending the client an empty client ID extension in the certificate request message from the server. Next slide. And then the client in its certificate message includes the Dane client ID extension. So that can be an empty extension to convey the client's intent to be authenticated via Dane. In that case, the server needs to extract the client identity from the certificate. And also it could be used to convey the client's name as well, which, as I mentioned previously, is required in certain use cases. For example, if you're using raw public key authentication. And next slide. And lastly, what the TLS server then has to do is get the client's identity, look up the TLSA RR set, authenticate it, and match it against the client certificate of public key. So in the draft is currently written, requires the TLS server to do this in band in the TLS handshake, but as has already been mentioned today in previous conversation, that's not the only possibility. We could envision the client kind of conveying, building its full Dane authentication chain and sending it along in a TLS extension to the server. The reason we hadn't originally put that in the draft is we were concerned that one of the prominent use cases for this protocol was IoT devices, which could potentially be constrained, and that may be too high of complexity and implementation bar for them. But since we're discussing it, we can certainly have a debate about whether or not that enhancement, whether it's optional or not, should go into this protocol. And next slide, please. Yeah, okay, so I'll stop here for discussion. One parting question before that to the chairs in the working group generally, though, is are these drafts suitable as protocol building blocks for dance? And if so, you know, when should we, you know, talk about adopting them?
So I'll see the question with one question that kind of came up in the chat, which is that device identities are potentially privacy leaking, and should we consider doing this only for TLS 1.3 and ignoring 1.2? Do you have thoughts on that?
Yeah, so I mean, when we were originally doing this work, TLS 1.3 didn't exist, right? So we had to kind of support it in TLS 1.2, and I had to grapple with the privacy question a little bit harder. Now that we have TLS 1.3, I guess it depends on you know, the use case and what kind of deployed field of client devices we're dealing with, right? So if it's the case that it's like greenfield applications where TLS 1.3 is omnipresent, then yeah, I think we could easily do that, but it may not be the case in certain environments, right? So I think that question, I don't know the answer to that question. I think it would need some research to see, you know, which sort of environments we're trying to apply these solutions to.
Okay. DKG, I suspect you're in line specifically because of that.
No, I actually had a question about the TLS
Okay.
arrangement. Can you go back to the slide that had the TLS diagram?
That
That's
one?
the one. Yeah. So I might be fuzzy. It's early in the morning in the time that I'm in. But I seem to recall that with TLS, the client has to offer the extension before the server responds with it. So are we saying that the client hello would be marked with the client ID, the Dane client ID as well? It's a request response arrangement, and I don't see it in the first flight from the client.
It's not in the first flight from the client, right? So that was in the original version of the spec when TLS 1.3 wasn't around. So
No, I'm
reason
not
we
saying the
moved it.
certificate. I'm saying the extension, because I believe extensions are request response. So if the client doesn't offer the client ID extension, then the server can't respond with it. That is just a flag that says I do want to do Dane client ID.
Yeah,
Right,
so I'm
and
a
the
little
index-
fuzzy about that. I don't see why. I'm not aware of that requirement, so maybe someone can elaborate on that restriction a little bit more.
Yeah,
So in this
I think he's
case,
right.
I mean, the,
Problem. So
that's just a wrinkle that's worth thinking about. The second thing that when I'm looking at this, it occurs to me that if this is being done in a situation where you basically already know your peer, and you have you have no other way to authenticate yourself besides this client cert, there's no necessary reason for an extension for this at all. In fact, you've already identified that the server is who they say they are. And if you know that this client identity is visible, you can just stuff the information into the certificate and let the server figure it out. I'm not even sure that we need a TLS extension for that. If we have a standard way to say, construct a phony X509 certificate, you know, with especially, you know, mark it in some way, then you can let the server take it or not take it, and that's how it is. You might not need the TLS extension at all.
yeah. So yeah, so Daniel, I agree. There are many situations where you may not need this at all. So there are situations where you might, though, right? If you have a kind of like a mixed mode field of TLS clients, and some of them can do Dane authentication, some of them can't. You want a signal from the TLS client to the server that I have, you know, please authenticate me via Dane. Otherwise, the situation you're going to run into is the TLS server may be needlessly trying to do all these Dane lookups in band with the TLS handshake for many clients that have no Dane record, and it's doing useless work, right? So this is kind of optimization to make sure the server is not being compelled to do unnecessary work.
So I think you actually need the signal in the opposite scenario. In the scenario that you're describing, we don't need a TLS extension signal. We just need the certificate to be identifiable as a Dane cert versus not a Dane cert.
Fair enough. Yeah, that's another way to do it. If the certificate contains some sort of attribute that tells the server that it has a Dane record, that would be another way of doing it. So I think that's worthy of discussion. Yeah.
Yeah, and there is the opposite scenario where you have a client that is connecting to servers, and the client has multiple ways to authenticate and needs to decide which way to use. That's where you would need the TLS extension, so that the server can signal which type of identity the client should use. If we're talking IoT, that seems like pretty unlikely, right? These devices are going to have one identity to offer.
Correct. Yeah.
Okay.
So I mean that second point is already satisfied by the server optionally providing that extension. So maybe it should always provide that extension if it knows it supports Dane client authentication.
Shuman, I feel like I maybe misunderstood the deployment use case. Sorry, I got.
Yeah, I'm hearing a little bit of an echo. Should I mute myself or?
Not going to reverb here. Yeah, so we were just talking about can we go to TLS 1.3 only? And your observation was, well, we might be able to, but we need to check the kind of the use cases and the user population of the devices. That confused me a little bit because I thought we were talking about a greenfield deployment. So, regardless of whether I'm using TLS 1.2 or 1.3, I'm going to have to update my stack here with this extra Dane kind of and logic. And so, are we saying we have circumstances where we can update the code to do a slightly better or fancier TLS 1.2 processing, but there are certain clients where, while we can make that change, we can't make the stack upgrade to 1.3?
Yeah, so that I don't know. You may very well be right, Roman. So I was envisioning a situation where, you're right, stacks have to be upgraded regardless to use this mechanism. But there may be situations I was imagining, I could be wrong, where it's easier to just enhance the TLS 1.2 stacks to do this rather than upgrading whole hog everyone to TLS 1.3 first. I could be wrong about that. Maybe that's not a concern, and we're looking more at greenfield TLS 1.3 deployments.
Ben?
Hi. I'm getting echo too. So you mentioned the question of whether sending an entire chain would be a significant burden on IoT devices. I want to argue that it's not a significant burden, that from the perspective of an IoT device, the entire chain is a static block of opaque data. It doesn't need to know anything about it. It doesn't need to look at it. It just would need to ship it in the handshake or alongside the certificate message. Because this block of data only changes when, at most as frequently as when the certificate itself has to change.
So Ben, I think there's a little bit more subtlety here. It has to change more frequently than that. It has to change as TTLs and RSIGs on the time scale of those things in the chain, right? It's a full chain. So it's not just the TLSA record in the leaf zone, but it's all the records above it too.
Okay, that's
so it has to be. Right. I mean, not that it's not doable, but I mean, something has to like periodically regenerate the chain for the client. Right. So either the client is doing it itself, which may or may not be a computational burden for them, or some out-of-band thing is doing it for them.
Yeah. Okay. I see your point here. You can actually rotate the in the sense the intermediate keys more frequently than you rotate the leaf keys. That seems a little weird, but you can do that. And then
I mean, in theory, you have to be prepared for the possibility that it could happen, right? Which means you want to be able to always ship a reasonably fresh TLS chain always, right, to prevent those kind of problems.
Okay, that's interesting.
Typically, the upper tree has longer longer signatures, but
Yeah, I agree.
longer-
Typically longer may not be an issue, but it's like there's no guarantee of that in the general case. I think.
Okay. Thanks for helping me understand that. My view here is that we want shipping a chain to be something that servers can require, essentially a profile of this whole system. So that I don't think it has to be mandatory, but I think servers should essentially be able to mandate it for some population of clients that they work with.
Okay, yeah, I think that's a reasonable thing to suggest.
Victor, and if I could beg you to give an explanation at the same time of the difference between TLSA expiry versus signature versus expiry, because there's discussion in the chat, and so I think we might actually clear up some of the chat discussion if you want to go over that road.
Okay, I was actually going to that point. So to clear that up, yes, the client needs to actually, if it's going to send the chain, it would need to regenerate fairly frequently, because one of the most essential elements in that chain is the RR-sig over the client's TLSA records. And while the client's public key may be stable for days, weeks, months, years, the RR-sig over that key from the signing zone should really only have validity at most a couple of weeks, maybe a month. And so the client would need to refresh that data from time to time. Needn't be on every exchange, but it would need to do it periodically and well in advance of the expiration of the resource record signatures on this data that it obtains at some point and needs to again have a fresh copy of realistically every few hours. I signed TLS records for 1 hour. I don't know if that's enough, but
Yeah, just to
volatile element of this data. The rest is fairly stable.
Yeah. So just to elaborate on that point, Victor, it's even if nothing else changes, the RR-SIG's inception and expiration parameters will change, right? Those will gradually change, and those are part of the data over which the signature is computed.
Right. Well, the RR-SIGs are the signatures. They're not. You don't sign RR-SIGs, but yes. But the dates, yes, are in
Yeah,
fact
dates. I mean, it's RR-SIG the metadata of the RR-SIG
Right.
is included as part of the signature.
Right. Mm-hmm. And those should not be, IETF.org aside, which signs for 1 year, as a bad example. The rest of the world signs for much less time. One thing I wanted to point out in terms of this slide and the various extensions going back and forth is that, in fact, a lot of this signaling could be embedded in existing signaling, in the sense that if we wanted to go down that route, when the server solicits a client certificate, it sends a list of acceptable CA names. CA names are subject DNs, and subject DNs have components, OUs and countries and all that kind of stuff. And there could certainly be a format for the subject DNs of the CAs that the server requests that essentially implies a DNS namespace. And could even, say, I want a client credential issued by essentially Dane from this domain. And that could be a form of, X509 name. All we need to do is get an OID. OIDs are free. We could, write one down on a napkin, and then we have a way of signaling that you want. If that name component appears in the certificate list from the server, that means that the server is willing to accept Dane identities from this portion of the DNS tree. Similarly, the client certificate could, at least in the use cases where the TLSA records are of the Dane EE variety, right? 3, just carry a public key essentially. The client can mint its own certificate on the fly, right? Because all it's presenting is a public key. And then it can embed in that certificate any name it chooses at that point in time or has chosen recently. So it can again signal its name in a freshly baked cert to indicate, I am so-and-so at such and such a domain. So there's lots of opportunities to move the signaling from extensions into bits of, certificate-like metadata that we could consider, if appropriate.
It would be well worth writing up an example vector and sending to the mailing list so that people can read it over. I think that's a really good point.
And at some point, I may think harder and deeper about the role of an architecture in which we have things like KDCs mediating multi-hop interactions here. And then we potentially take advantage of existing protocols there, maybe even get advantages in terms of post-quantum and so on. If KDCs negotiate symmetric keys with each other periodically, then we can use symmetric keying for bunches of this. Anyway, all kinds of interesting stuff to research, but later.
Yeah, sounds good. So I think DKG brought that up as well. I think it's certainly worth investigating whether we can provide the Dane signal inside the certificate itself rather than in the certificate extension. So, yeah.
Are there any other questions or people that want to join the queue about the solution documents at least? We have plenty of time left. We still have 20 minutes left. Oli? No audio from you. I think I saw bars. Nope. Nope.
Maybe have Ollie type his question into the chat.
You could do that and we could relay it, certainly. We have microphone problems in physical rooms too, right? All right. Anybody else have comments so far? Otherwise, we'll probably dive into next steps. And Oli, whenever you're ready. Microphone's there. You don't need to request, just talk. Oh, you are super quiet. I actually hear something now.
Yeah, I can hear you extremely faintly, though.
That is weird. I just wanted to point out the namespace needs to be discussed. I had a discussion with the DNS folks, and they want us to look into the namespace so we build a DNS tree if possible. But that's something we can discuss later. But, I think that's in the architecture document. That's something we need to consider.
Okay, so I heard, I think I heard namespace needs to be discussed. Did I get that right? I was having a lot of difficulty.
Yeah, I think that was the brunt of it. Oli, could you actually just type your comment in Jabber just so we can record it in minutes, if nothing else? But I think that's a valid point, and we sort of mentioned that earlier as well. So, okay. All right. If there is nobody else joining the queue, I will talk for a few seconds to make sure that nobody else joins the queue. Yes, and the namespace needs to be discussed so that we build a tree instead of a flat namespace. Okay, valid point. Nope, nobody's joining the queue. So the next question, I think, to the participants in general is at what point we want to consider adopting these documents. I believe, Shuman, that you have said you believe that the two solution documents are functionally ready if the working group feels that that is the case. Is that correct?
Yeah, I think so. I mean, they may not be complete, but they kind of like appropriately address the capabilities that we need.
Right. You're willing to turn them over and have the working group rip them to shreds and completely rewrite them. That's what you said. Got it. Okay.
Yes.
All right. Having said that, does anybody have opinions, pro or nay, with respect to adopting the two documents as is as a starting point? Paul's back.
Back, but I've just been muted because I don't think things will work well for me.
So let me actually start a poll then. Do documents are ready? The two solution documents are ready for adoption. Note that this is not the architecture document. They're not ready. It's a good point, Roman. I'll get back to that. So in chat, it would be helpful if people that have read the documents would just say read, so that we get a feel that you know, the counts actually match people that have actually done a at least a brief summary and analysis of it. Thank you. Keep those up. Gotta love English. The fact that read and read are the same spelling has always just, if there was one abomination of this language, it would be that. Yeah, that too, Ish. All right. I think that is a fairly clear consensus that we are trending toward they're ready. The numbers seem to be mostly stable. So we will end the session there with 22 for raise hands. 1 did not raise hand out of 23 total participants. I didn't count the number of people that have read things in this session, but in the Jabber session, but it seems to be there's quite a bit of people that have read it, so that's a good sign. All right. Having said that, I think I'm out of questions unless my illustrious co-chair or AD has specific things they want to bring up. And we can give you back 13 minutes of your day. Going once. In DKG?
I just wondered, I saw that one person said this document doesn't seem ready for adoption. I wonder if that person wants to say anything. It just might be worth hearing what they think is missing.
Yep, that's a very good point. Thank you for that. If the one person that did not raise their hand wants to de-anonymize, please feel free to come to the mic and explain why you think it's not ready yet. Understanding that you may not want to de-anonymize, and that is the purpose of a anonymous poll. So. All right. Well, hopefully discussion will come up on the mailing list of what people find issues with the current document, because that's the purpose of editing things as a working group in the first place. So thank you, DKG, for making sure they had a chance. But otherwise, I think we'll close the inaugural session of the dance working group, and we can all take an extra 10 minutes to get some exercise. And I suggest dancing. It's a great form of exercise. Thanks all. See you in 113.
Thanks all.